lifestyle versus drugs, number one, it's not either or. Like, I think there's a place for both. But lifestyle probably has to be the foundation on which you build a better Healthspan trajectory.
This is the Home of Healthspan podcast, where we profile health and wellness role models, sharing their stories and the tools, practices, and routines they use to live a lively life. Dr. Kaeberlein, I am personally so excited for this conversation. I've gotten more questions from our listeners than any other guest ever in the show. So I don't think we'll have time to jump in on all of them, but I can't wait for our conversation. Before we jump into those, though, how would you describe yourself?
I'm a lively husband, father, scientist, mentor, trying to improve health for as many people as I possibly can.
Yes. And I think it's well documented. You are doing that at a tremendous scale, more than 200 scientific papers published, part of the American Association for Advancement of Science, American Aging Association, so many others. But I guess it all started before now, right? This was years leading up to where you are now. Could we go back to some of your early work on sirtuins at MIT and kind of what ended up launching you into this space?
Sure. And I mean, it was really that time in my life that set the stage for the rest of my career. So I went to graduate school at MIT thinking that I would study protein structural design, X-ray crystallography, something like that, because that was really my background. I had undergraduate degrees in biochemistry and mathematics, and I looked at biology through a very sort of biophysical perspective or lens. And I heard a talk during my first semester at MIT by a professor there named Lenny Guarente, who I ended up doing my PhD thesis with. And Lenny gave a lecture about how his lab, within the last 5 or 6 years, had started studying the genetics of longevity. And in this case, it was in a single-celled organism, budding yeast. David Sinclair, who was in the lab at that time as a postdoc, had recently, within just the last year, published a paper on what really I think was the first proposed molecular mechanism of aging. And so that talk captured my enthusiasm and interest. I'd never thought about aging as, first of all, a biological process, and secondly, something you could use genetics and molecular biology and biochemistry to study. So I went and I talked to Lenny, ended up joining his lab. And when I started in the lab, through a series of conversations with people in the lab, and in particular, David, decided to really try to look at the role that a protein called SIR2 played in the aging process. At that point, nobody was thinking about SIR2. And this gets in the weeds a little bit, but Brian Kennedy, who's also pretty well known in the field, a fantastic scientist, had done early work. Brian was actually one of the 2 first graduate students who got Lenny's lab working on aging, along with Nick Austriaco, who ended up becoming a Catholic priest after graduate school. There's a whole story there. Anyway, Brian and Nick had sort of looked at a different protein called SIR4, and they were focused on SIR4 as a key player for longevity in yeast. And David had published this model about the ribosomal DNA being very important for aging. That's that molecular mechanism. And so I kind of, through looking at the literature and through a little bit of detective work, developed the hypothesis that it really wasn't SIR4. It was this neighbor of SIR4, we'll just put it that way, they act in the same complex, SIR2, that was really the important factor, because it was at the rDNA and at the telomeres, and all of that was kind of making sense, put the puzzle pieces together. And so I started studying that. And eventually, along with another graduate student in the lab named Mitch McVeigh, we did, I think, what was really the seminal experiment around sirtuins. And I'll talk about how SIR2 is related to sirtuins in a second, in case that's not obvious. But what we did was we overexpressed the SIR2 protein in yeast, and we showed that that was sufficient to increase lifespan and slow the aging process. And so that really established SIR2 as a central player in aging in yeast, right? And this is all in yeast. So, we don't want to get too excited yet about how relevant that is anywhere else. And then it was a really exciting time in the lab because, David was there. Another great scientist named Shinichiro Amai was there. Heidi Tissenbaum, who went on to do a lot of important work on longevity, was in the lab. At this time, nobody knew what the biochemical activity of SIR2 was. Shin, and I was fortunate to be able to play a role in this as well, discovered that it was a new kind of what's called histone deacetylase. It was a fundamentally new chemical reaction. It's called NAD-dependent histone deacetylation. And he found out that's what sirtu was doing. It was carrying out this reaction. And not only that, there were a whole family of these proteins that look like sirtu structurally. That's where the word sirtuin comes from. Sirtuin, the family of proteins that look structurally like sirtu. So Shin basically discovered, I mean, obviously this is Lenny's work because it was all done in his lab, but Shin was the person who did the actual research, discovered that sirtuins are this family of NAD-dependent histone deacetylases. And Heidi showed that the sirtuin from worms increased lifespan in worms. And suddenly we had this really, I think, compelling, exciting story that the whole field got enthusiastic about, that this isn't only a yeast-specific story. It connects epigenetics. That's what histone deacetylation is. It's an epigenetic modification. It connected epigenetics to aging through these sirtuin family of enzymes. And another postdoc in the lab, Suju Lin, had developed a model that caloric restriction was working through sirtuins by affecting NAD levels. So it really created this whole complicated but elegant model for a potentially conserved mechanism of aging involving this family of enzymes called sirtuins. So by the time I graduated, when I joined Lenny's lab, nobody was studying sirtu. I was the first person in the lab to really start working on it. And by the time I left the lab 4.5 years later, everybody in the lab almost was working on sirtuins in one shape or form. And so it was sort of a fundamental change in Lenny's lab's focus. And a lot of people in the field got excited about sirtuins, and this led to probably 10 years or so where sirtuins were probably the most talked about and studied factor in the longevity space.
Yeah. And so I guess it's a initial study that launches almost a field, right, around all of this.
Yeah. And I mean, we may talk about this. In some ways, it was a double-edged sword because, I think as we learned, that sirtuin paradigm turned out to be overstated. I think certainly, compared to 2005. So I was in Lenny's lab from 1998 to 2001, late 2001, early 2002. By 2005, a lot of people were excited about sirtuins. And so from 2003 to 2010, it was a dominant paradigm in the field. I think if you ask anybody now, some people still think sirtuins are important, but nobody thinks they're the quote unquote master regulator of aging. That's how people talked about them back then. And a lot of resources went into trying to prove how important sirtuins were. And I think we learned out a lot of they're not as important as people thought, right? So it did lead the field astray a little bit, I would say, because so much it sort of became a dominant paradigm in the field that wasn't really as solidly backed up by the data as a lot of people thought.
That makes sense. And so as you left, what was the genesis or the path as we move over and look at mTOR and maybe your work with rapamycin since then?
I mean, it's a really interesting path for me personally. So I left graduate school. I spent about 1.5 years in a startup biotech company called Longenity. This was in Boston, that was started by a guy named Pete Eastep, who came from George Church's lab. And we were 20 years before our time because Longenity was about building biological aging clocks before anybody had ever thought about aging clocks, right? We didn't call them clocks. We called them biomarkers of longevity. But that's what we were trying to create were these tools that would allow us to predict future longevity for individuals. So anyways, 20 years too early. I spent about 1.5 years doing that. And then when my wife completed her PhD, she was at Northeastern at the same time, we moved back to Seattle, to the University of Washington, both doing postdocs there. I did my postdoc with a sort of famous scientist in the cell biology world named Stan Fields. He developed something called the yeast-to hybrid assay. But Brian Kennedy had relocated to the University of Washington. He was an assistant professor there. And Brian and I knew each other from the Boston days. And we had, of course, the shared background of being in Lenny's lab, even though we didn't overlap as graduate students. And so we sat down, very early in my time at the University of Washington and both continued interest in the biology of aging. And I think we both rapidly realized that we shared the feeling that the field had become way too focused on a very small number of genetic pathways, sirtuins being one of them, insulin-like signaling, IGF-1 being another. And there was a lot more to discover, and that we wanted to go and look more broadly instead of really trying to drill deep on these known pathways, figure out what we don't understand about the biology of aging. And so we set out to carry out one of the very early, what are called genome-wide screens for genes that affect longevity. And again, we were working in yeast. Other people at the same time were working in C. elegans. And so we created this system where we could screen a large number of genes one by one in yeast and find genes that when we deleted them increased lifespan. And we just started plowing through the genome. And we got kind of lucky that in the first 500 or so, mTOR happened to be in that set. We didn't pick it. I wish I could say we were really smart and we knew mTOR was going to be important and we went after it. Nope, we got lucky. It happened to be in the first 500 that we tested. When we knocked down mTOR, it increased lifespan in yeast. And again, through sort of what happens in science sometimes, completely independently, 3 other labs stumbled on mTOR as a regulator of lifespan, 2 of them in C. elegans, 1 of them in fruit flies. And so there were these 4 papers that came out all within a year of each other, reporting that when you turn down mTOR, you increase lifespan in 3 different organisms spanning billions of years of evolution. I mean, this had to be important, right? And the fact that we all independently found this, I think also gave a lot of confidence that it was real, right? That it's not just one lab that's doing all of the work in this area. And so, so I immediately, when we found that deleting mTOR, or TOR1 in yeast is the yeast version of mTOR, increased lifespan, I immediately went to the literature. I'd never heard of rapamycin before this. I went to the literature and what do we know about mTOR? And it turns out that mTOR is regulated by nutrients. So it was a very reasonable hypothesis that this was part of the caloric restriction effect on lifespan. And there's this drug, rapamycin, that's an inhibitor of mTOR. So we deleted one of the 2 TOR genes in yeast and increased lifespan. It made sense that the drug, which turns down TOR, should have the same effect if we gave it to wild type cells. Turns out it did. So we published that in 2006, which was really the first paper that ever reported lifespan extension from rapamycin. And then now, what are we, almost 20 years later, we now know that in every animal where rapamycin has ever been tested, it is capable of not only increasing lifespan, but seemingly slowing the biological aging process at the organ, tissue, cell, molecular level. So this is sort of, and again, I feel grateful that I've had a role in this, but this is lots and lots of labs, dozens of really, quality scientists, probably hundreds of papers at this point in many different model organisms showing that rapamycin or turning down mTOR through other ways can have this effect on aging. So it really is, second to caloric restriction, the most studied pro-longevity intervention that's out there, and also second to caloric restriction, the most robust, probably even more than caloric restriction, the most reproducible. So it really is in many ways a gold standard intervention for slowing aging, at least in the laboratory.
And I definitely want to dig on that and that juxtaposition. Before you do, you were saying in every organism is tested. You're doing work now with dogs.
Yeah.
Can you kind of speak to what you're seeing there?
Sure. Yeah. I mean, I wish I could tell you I knew the answer. So this is as part of something that's called the Dog Aging Project, which is a large, mostly observational study of aging in companion dogs or pet dogs living with their owners. So this is very different than, all of the work that I was involved in before we started the Dog Aging Project, in that, this is outside the laboratory, real world, dogs living with their owners. And so, as I said, most of the Dog Aging Project is observational. We're not asking owners to do anything different. We're collecting data, biosamples on the dogs, and to try to understand what are the most important factors that influence health outcomes during aging. So, as part of the Dog Aging Project today, there are more than 50,000 dogs and owners participating around the United States. It's a very large, probably the largest study of aging in the world. But a piece of the Dog Aging Project is a veterinary randomized placebo-controlled clinical trial testing whether or not rapamycin can slow aging in dogs. And when that's fully enrolled, there will be about 580 dogs participating in the clinical trial. It's about half enrolled right now. The goal there is to test whether or not rapamycin slows aging in dogs. And the primary endpoint is lifespan. So the number of dogs combined with the entrance criteria, so the dogs have to be at least 7 years old and between 40 and 110 pounds, we believe gives us statistical power to detect a 9% change in lifespan. So that's the primary endpoint.
Okay.
But of course, we're interested in Healthspan, and we're looking at a variety of Healthspan metrics: heart function, neurological function, activity, disease incidence. Really trying to assess whether rapamycin can improve health, broadly speaking, in dogs. And so that study's ongoing. So what I can tell you is before we started this it's kind of equivalent to a phase 3 clinical trial. We aren't going for FDA approval, but if you were, it's kind of equivalent to that. We call it Triad for test of rapamycin in aging dogs. Before we started Triad, of course, the first thing we had to determine and establish is that this was safe, right? So we did 2 safety studies. One was 10 weeks of treatment. One was 6 months of treatment. In both studies, the dogs got echocardiograms before and after to look at heart function. And I would say the signals were going directionally in the right direction, where we saw evidence for improvements in age-related heart function, in particular, some metrics of left ventricular function, which other people in mice had shown rapamycin could improve. So, I don't want to make too much of it other than to say the arrows were going in the right direction. These were small studies. Some of the measures were statistically significant. So that was good. We definitely were able to establish safety. We didn't see any evidence for significant adverse events, and that still has held up, even though Triad is still blinded. We've got a monitoring committee, data safety monitoring board. We haven't seen any evidence that rapamycin is having side effects in the dogs. The other thing, and again, it's not something I want to make a lot out of, but in both studies, the owners were blinded, the veterinarians were blinded, we were blinded, and in both studies, the owners self-reported in improvements in activity and quality of life. So, it's going in the right direction again.
And that's really probably the biggest health span indicator, especially if it's blind. It's like, wow, my dog's acting much younger.
Exactly. Yeah. So encouraging, I would say.
And for that, the dosing, because I think this is, Peter Thiel often mentioned with fasting, right? It's like we have this miracle drug, but we don't know the dose and frequency or anything. And with Rap, I think that's a common question for a lot of people as well. What is it for the dogs?
So the dose we're giving in the current trial is 0.15 milligrams per kilogram once a week. The first trial, the 10-week trial, we did 2 doses, 0.05 and 0.1 milligrams per kilogram given 3 times a week. And it's all guess. I mean, it's educated guess, but these are guesses. And that's one of the hard things about clinical trials. I don't think people really realize this. When you're designing a clinical trial, you're forced to make a series of educated guesses, right? And then you have to live with them. And so you hope you do a good job. And dose is one of them. I'll come back to dose in a minute. Another one people don't think about, but the one that actually keeps me up at night, not that it really does keep me up at night, but that I worry about with our rapamycin trial is because we wanted to make this a trial of healthy aging, one of the exclusion criteria were the dogs could not have a significant pre-existing age-related condition. It makes sense. And it creates a healthy cohort bias because now the dogs we're enrolling are healthier than the average population. It's harder to see a positive effect on health if you're starting from an overly healthy population. So these are all the kinds of things you have to try to do the best you can, and then you live with it. So coming back to dose, the reason why we started with 0.1 and 0.05 mg per kg 3 times a week is because when I was designing this trial, we had no information on rapamycin in dogs other than two groups were studying rapamycin for different types of cancer in dogs, one osteosarcoma and the other hemangiosarcoma of the spleen. And both of those groups were using this 3 times a week dosing. And so they were generous enough to share their safety data with me. And so I was trying to figure out, what's a dose that might have efficacy, but that I'm very confident will be safe over the time frame of the trial. And so that's why we started with those doses. And the reason why we moved to the once weekly dosing for the next 2 trials, including Triad, is Joan Manick has published a couple of papers now with a derivative of rapamycin called everolimus in humans, where they showed that you can get similar efficacy with a better side effect profile at once weekly dosing versus daily dosing, roughly comparable overall total doses. And that's what most of the off-label use of rapamycin has gravitated towards is once weekly dosing in humans.
At like 6 to 8 milligrams typically. Yeah.
Yeah, I mean, it's variable. So 6 is the most common. It's probably 3 to 8 is the this ballpark standard deviation range, but 6 is the most common dose. A little bit of variation for women and men. Women usually taking a little bit less, but almost, I would say probably 90% of people using rapamycin off-label. And what I mean by that is just not for the on-label indication, which is usually going to be organ transplant rejection, is once weekly. So probably 90% of people are taking it once weekly. And the normal curve standard deviation is going to be 4 to 8.
Okay. And I mean, not that we give medical advice, obviously, all the disclaimers on the show, but do you currently take rapamycin?
Yeah, I mean, I'm not taking it right now. I usually cycle 3 months on and then 3 to 6 months off. And my personal dosing has ranged between 6 and 10 mgs a week. It turns out I'm a fast metabolizer. I know that because I measured it in my own blood. So I probably can tolerate a little bit higher doses than other people can. And that's the other thing. Most of that, certainly for off-label dosing, very rarely does anybody personalize the dose to their own state, right? And this is actually something that's worth saying about rapamycin. Unlike some of the other interventions we might get to that are popular in the longevity off-label community, we don't have great biomarkers for rapamycin. We don't have a good way to say, yeah, this is the right dose for you, because we don't really know what the right biomarker is.
Most corporate wellness programs overwhelm employees with too much, or they offer too little to be useful. Lively gets it right. We start with each employee's data and goals, then serve one clear, personalized action at a time. No noise, just real behavioral change. The outcome? A healthier, happier workforce, and measurable impact for your business. Visit alively.com to see personalized wellness in action.
I've heard you say in the past, the two that you see the most justification for are RAPA and then SGL2.
Yeah, SGLT2 inhibitors, Canagliflozin and pagliflozin, yeah. So first of all, just for people who don't know what those do, I mean, basically they just make you pee out more glucose. So they're an inhibitor of a co-receptor, co-transporter in the kidney that causes reuptake of glucose. And so when you inhibit that, you pee glucose out in your urine. So the effect is it lowers circulating blood glucose levels. Over time, at least for many people, it will also lead to an improvement in insulin sensitivity, probably because you have lower average blood glucose levels. So it's been approved for diabetes, also some evidence for benefits for kidney function, potentially cognitive function, cardiovascular. But the reason why people are excited about it for longevity is because it also has been shown in animal models, in mice in particular, to increase lifespan. This has come out of the interventions testing program. So it seems to slow biological aging in laboratory animals. Definitely beneficial for people who are metabolically impaired, and some evidence for other potential benefits in humans. Now, the nice thing about SGLT2 inhibitors is we've got a really, really great biomarkers to tell whether it's working for you. Is your average circulating glucose lower? And is your insulin sensitivity getting better? If it is, you're in the right range, right? So this is where I think it's kind of a very different beast than rapamycin. I personally feel a lot more comfortable about SGLT2 inhibitors because we know what the biomarkers are to look for. And if we're seeing improvements in insulin sensitivity for the vast majority of people, I think that's a pretty good bet that their health is going to be better. Maybe their longevity is going to be greater, but their overall health is going to be better going forward.
One other one that has been mentioned kind of in passing since we started talking, but I think the question is, as a supplement, does it actually work? NAD. So, people are doing IVs, doing shots, trying patches. I'm getting all this on social media from Rose liposomal formulation. Yeah. What are you seeing there? Like it's one of those theory and practice issues, it seems.
So, I mean, I think there's no doubt in my mind that the whole NAD thing is way overhyped compared to the data. The data is interesting. It's also very mixed. So I think what I can say with confidence is NAD levels in laboratory animals decline in some tissues with age, but the idea that NAD declines globally with age is mostly bunk, but it's not supported by the bulk of the evidence. That's probably true in people as well. So that's overstated. There's probably some truth to it. And it's probably individual, right? So NAD, again, for people who maybe aren't aficionados, it's a cofactor in thousands of reactions in our cells. Many of them are metabolic, but not all of them. DNA damage, repair, bunch of other functions. So it's important for lots and lots of different cellular chemical reactions, and it's essential for cellular function. And so for that reason, NAD levels are very well buffered in our cells, right? It takes a lot to move NAD out of the range that it needs to be in for our cells to function. So the idea that NAD levels are dramatically declining with age just it's not biologically plausible. So then one question is, do NAD levels decline enough with age that they're impairing cellular function? And I think in some people with significant metabolic perturbations, that's probably the case. So, for example, in people who have severe mitochondrial dysfunction, inherited mitochondrial diseases, you will have a depletion of NAD to NADH, which is the reduced form of NAD. And then in order to restore NAD, your cells will make lactate. That's why lactic acidosis often happens in people who have impaired mitochondrial function. It's also why you get lactate buildup when you're exercising, to extreme levels, right? That's to regenerate NAD. So that's a mechanism that our body uses to maintain NAD homeostasis. This is all, I'm just trying to make the point. It's really hard to get our bodies to a place where NAD is limiting, right?
Yeah.
So then, so I think the real question is, what evidence is there that if we boost NAD, that's going to be beneficial? And then I think a secondary question there is, of the various ways that people are trying to boost NAD, which of them actually boost NAD? Because it's not always the case that that's clear. So I would say for longevity, the data in mice is very unconvincing that NAD boosters increase lifespan. There was one study from the Outworks lab that failed to be replicated with nicotinamide riboside. There's another study from the Sinclair lab where the supposedly long-lived mice on NMN are actually shorter lived than control mice should be. So weak evidence, and that hasn't been replicated. So I would say it's very unclear in mice that NAD boosting slows aging. There are some mitochondrial disease models or Parkinson's disease models where boosting NAD appears to have therapeutic value in laboratory animals. And that's the only data I find even moderately convincing in humans at this point is in Parkinson's disease. There's a signal, it's early, but there's a signal with nicotinamide riboside that it may have some benefits in people with Parkinson's disease. So my intuition is there are certain metabolic perturbations where boosting NAD, probably because you're restoring the NAD to NADH balance, is beneficial. Is that going to translate to the average person as you're getting older? I don't know. I will say, anecdotally, in talking to physicians who use, NAD drips, I've talked to some people who seem pretty credible, who say in some of their patients, people have sort of remarkable improvements in quality of life. So I believe there are certain conditions where boosting NAD can be quite beneficial. I just don't think we know at this point who it's going to be beneficial for and who it's not going to be beneficial for.
Yeah.
And then there's a lot of noise around, is NMN capable of being taken up by cells? Is NR capable of being taken up by cells? It all gets broken down by the microbiome to nicotinamide anyways, so does it matter? I find the sort of bickering back and forth among people in the NAD space to be a bit comical when they have yet to establish that these things are actually useful.
Yeah, it makes sense. And you touched on they're the couple that you say, hey, we actually have good evidence that these work, and some we know the mechanisms and can track. And then there's a long list of others. But before we talk about some of that, I'd be curious because you also compared it to, I think, the number one intervention we do know or seem to know for extending longevity is caloric restriction. Yeah. And this whole world of behavior and lifestyle change versus maybe molecules. Because I think when we met at the TEDx Boston Unlocking on Longevity, you had the chart showing, hey, rep is the best thing that we know. And here's where it sits next to caloric restriction. Caloric restriction is still outside in terms of extending life. So especially with your work at OptiSpan, where you're balancing both, what do you see the weighting on how we should think about these two?
That's a great question. So before I dive into that, I do want to explicitly make the point. So in laboratory animals, caloric restriction can have the biggest effect on lifespan that we know of, right? And it's about twice the magnitude of rapamycin, which is the second biggest effect on lifespan. So that's just useful to understand in terms of, what we're talking about. And that's lifespan. So when you start talking about health span, which is I think what most people are more interested in, or many people are, right? Yeah, it's harder to assess because there aren't very many studies that look broadly at health span in laboratory animals. It happens sometimes, but usually you have to aggregate a whole bunch of studies that looked at one health span metric for rapamycin or one for caloric restriction. The thing I would say is, and this is my take on the literature, but I think most people who are broadly read in the field would agree with this, both caloric restriction and rapamycin seem to improve a variety of health span metrics across many different tissues and organs in mice. Okay. But when we go to people, I think we really want to be cautious about caloric restriction because mice in the laboratory aren't dying from fractures or frailty or infections in general because they're in a relatively sterile environment. Those are the things that I get really concerned about, the level of caloric restriction that we apply to mice. If we were to apply that in people, I would be very concerned that people are going to experience frailty, fractures, and high risk of infection, both bacterial and viral. Because we're talking about, 60% caloric restriction, 800 calorie diet, right? A day. So I just want to make that point that when we get to the lifestyle discussion, I don't think that level of caloric restriction makes sense in humans, even if we could do it. I just don't think you're going to make people live longer. I think it's going to have detrimental effects outside of normal aging biology that are going to offset the benefits. Do I believe caloric restriction slows biological aging in people? Yeah, I can't prove it, but my intuition is it does, given the data that we've got on, clocks and other markers of aging. And it's not a long-term strategy for increasing your lifespan, or certainly not for improving your quality of life, in my view. So that's where I land on caloric restriction. I just think it's important to say that because when you talk about caloric restriction in mice, all of a sudden people are thinking that, you extrapolate that to humans, they should start eating a severely calorically restricted diet. Now, to get to the question of lifestyle versus drugs, number one, it's not either or. Like, I think there's a place for both. But lifestyle really probably has to be the foundation on which you build a better health span trajectory. And, at OptiSpan, we talk about this as 4 pillars. You can have everybody has their different number of pillars. We talk about 4. We talk about eat, move, sleep, connect. Active words. I like active words. So eat is, of course, diet, nutrition. Move is exercise. Sleep is obviously sleep quality. And connect encompasses both mindfulness and the importance of human relationships, social network. And stress weaves its way through all of those. So some people like to put stress as its own pillar, but it really, all of those things influence the stress you experience and the way you manage stress. So that's how I think about lifestyle. And maybe I go back and forth a little bit in my own head over time, but I can't say with any degree of confidence or emphasis that one is more important than the other. It's going to be different for different people, what the biggest levers are, but they're all super important. So I wouldn't try to put, one above the other. I think they're all important. And I think where drugs come in is drugs can help because sometimes you can have a pretty good lifestyle and you still got metabolic challenges. I think drugs can help there. I think like GLP-1, we haven't talked about GLP-1 agonists. Those can also help in getting people to a better lifestyle than they have currently because you can see improvements. And if you can reduce body weight, you can improve your ability to exercise or maybe your sleep quality if you reduce inflammation. Like, I think, so I don't want to say, like, I'm definitely not one of those people who says, you have to do it all through lifestyle and then you can try drugs. I think it should be a balanced picture. And for each person, you try to find, what are the biggest levers you can pull. And often, most of the time, there's going to be a lifestyle component to that. But sometimes there's going to be a pharmaceutical component. Sometimes there's going to be a supplement component that goes along with it.
Yeah, I mean, that's very much what we see. You probably saw the recent study from Gallup. Obesity has gone down for the first time in 20-something years, thanks to probably GLP-1s. And the cascading positive benefit from that. And so I think we have 5 pillars. We have stress and mindset as its own, but the same on the others. And we say the most effective thing is the thing you'll actually do, right? So maybe it's take a pill, but if you're terrible at remembering to take a pill and you're never going to take a shot or anything, but you will do this walk after each meal, then that's the most effective thing because that's actually something. The theoretical doesn't matter if you're not going to do it.
And I would simply add to that, it's also what you're going to be able to sustain, right? And that's why there really is no one size fits all solution for any of the pillars, right? So some of this is figuring out, what I think exercise is a really obvious example, right? Where, some people are never going to get on an exercise bike an hour a day, right? There's never going to do it, but they'll definitely go out for a hike 2 times a week. So find the modality that's going to work for you and be sustainable. And it can change over time.
I would also equate it to compound interest on investing, right? You think about Warren Buffett and Charlie Munger. It's that they did it so consistently for so long is how you built up the money. And my gym, there were these 2 larger ladies working out with my trainer, and they were crushing with clean and presses. And I said to him the next day, I was like, man, that was really impressive what they were doing. He said, oh, you have no idea. So one of those, when she came, was over 400 pounds and the other was 370. And when we started, it was just a little step. All she could do was just go in the step box. She was on 32 medications and she's down to 7. Just it's, you start with the smallest thing. It's not, hey, I'm going to start with CrossFit. You start where you are and you can compound. It's that she continued to show up day after day. You get those benefits.
I think that's really important. Yeah. I mean, I align completely with what you said, and trying to help people recognize it as a trajectory and a long-term journey, right? Again, you're not going to immediately go from 0 to 100, right? And nor should you try.
Like the whole point is it literally lasts a lifetime.
Yeah. And I mean, this is something that we try to emphasize, and I personally try to communicate as well is the journey should be the reward, right? It's not, I mean, yeah, we all have goals that we want to get to in terms of our future longevity and health, but you should be feeling the value the entire time, right? The journey is the reward.
In health or anything, right? I have a 9-year-old daughter, and I try to explain that to her as well. Like, I was a swimmer, her mom was a swimmer. She didn't enjoy it. And she was great, but she didn't enjoy it. And I said, you can be great as a novice, but you're not going to be great at the next level because you don't like going to practice. You're not going to put in the effort. You need to find, like, no one ever asked Messi to go practice. That all he ever wanted to do was play with a football, right? And so it's the same with the health. Like, you don't have to be carnivore. You don't have to be vegan. You just find something that's getting you good nutrition and stick with what works for you. That's really helpful and self-affirming that I'm thinking about it as someone similar that I respect so much.
Well, and I think, when you see so many success stories with people who are taking that sort of approach, right? That also reaffirms the power. And I mean, you mentioned these 2 women, that your trainer's working with, right? I think that's, for me, that's one of the most rewarding things about doing this, right? Is seeing. And it's very different. I mean, when you're a basic scientist, of course, you all hope that eventually, 20 years from now, something you discover will make it into the clinic and improve people's lives. It's very different seeing in real time or close to real time, these dramatic, life-changing impact that you can have, right? And sometimes it's detecting a hidden condition. Sometimes it's helping people get on this new Healthspan trajectory that's going to probably give them 15 more years of high quality life.
And on that, I would like to talk, your talk was a lot around being honest in this space. And when you talk about these stories, I mean, there's so many stories, right? TikTok videos, whatever, of, hey, this magical X, Y, and Z, oat, Zipic to take this molecule, whatever it is, that there's some fad people jump on. And is someone with such a credible voice, it's worked at the highest levels with some people that there are questions on some of that. What are your thoughts there? Because I recently had heard there was a period of time that it was actually the wealthiest that died more younger than the kind of middle part of the population because it was the snake oil. They were the ones experimenting with all this stuff and actually was shortening their life. And I certainly have a concern with that with self-medicating with all sorts of stuff out there.
I mean, it's super complicated, and the noise definitely swamps the signal in this space, and that's getting worse, right? So, I'm now preparing a short, just public service announcement on a YouTube channel that's basically completely AI generated, telling complete nonsense wellness advice, and using David Sinclair as his image, right? And as much as I struggle with some of what David says, this is taking it to a new level. So this is just going to get worse.
Oh, it's like a deep fake of David.
Yeah.
Okay.
Yeah.
Oh, wow.
Well, at least that's what they say. I'm going to give David the benefit of the doubt and assume he has nothing to do with it based on the content that's there. But yes, it's an AI generated, giving terrible, just absolutely terrible wellness advice. So, and that's all just to make the point. This is going to get worse with AI tools and with the fact that a lot of people are getting rich and famous by spreading misinformation. So I think as consumers, I mean, to some extent, people are going to have to develop strategies for separating the signal from the noise. And I think there are a few general rules. Number one, if it doesn't align with the 4 pillars or 5 pillars or whatever that we talked about, it's probably bullshit, because we know that's true, right? So that's one. If somebody lies to you, they're going to lie to you again. Yeah. Like, stop trusting people who lie. I just don't get this. And you look at the largest names in this space, and they are often documented repeat liars. I don't understand that. But I can guarantee you, if somebody has a pattern of telling you things that aren't true, it's going to happen again. So just stop listening to those people. I think this is not a perfect one, but I think you should ask yourself, does this person have both credentials and expertise on the topic that they are talking about? Credentials don't always matter, because there are some people with credentials that spread misinformation, and there are some people who do their own research. I don't care if you have a PhD, if you've gone and done the research and you have the information right. But I think those can be guiding principles, where if somebody doesn't have credentials and they don't have experience in the space and suddenly they're a longevity expert, probably not, right? So those are the kinds of things I think people can use to guide themselves. And then the other one, of course, is, what are they trying to sell you, right? If they're trying to sell you olive oil, I'd be a little skeptical of that person. And if they're using fear to control you, if they tell you things like the air you breathe, everything you eat is poisoning you, they're manipulating you through fear. So I think people need to recognize the strategies that the dishonest people in this space are using.
Certainly. And I mean, you also have to be careful, I would think, for confirmation bias, right? Whatever you want, you can find an argument for that as well.
You can. I mean, that's a harder thing because, and this is true in the scientific literature, right? You can go find, especially now with the AI tools that are available, you can go find a study that will support almost any position you want to take, right? Especially when it comes to supplements or nutrition. So that's a harder thing. I mean, it's hard for me sometimes. It's a harder thing if somebody says, look at this study. It shows that, I don't know, taking cranberry extract 4 times a day is going to keep you from getting dementia, right? You can probably find a study that kind of hints at that, right? And you just over extrapolate it, even though there might be 8 studies that then failed to show any connection. So again, I think this is where, if somebody has a track record of doing that, of cherry picking studies, and I think also, there's a push-pull I've noticed this in the influencer world, right? Where in order to maintain your status as an influencer, you have to constantly have something new to hype, right? And science doesn't move that fast. So if somebody's always on to a new thing every week, they're probably overhyping.
By the way, they're an affiliate for selling.
Or making it up, right? Yeah. So again, I think people just have to use a little bit of common sense and critical thought. And it's hard because, this is where I recognize when I see stuff, I'm like, well, that's complete nonsense. Why do people believe that? But I'm trained as a scientist. So I immediately approach things from the perspective of, you've got to convince me, not I'm going to believe you, right? You
started the null hypothesis and you have to go there.
So I think looking for alternative explanations and not being gullible are really important in this space right now. Otherwise, you're going to constantly be misled. Maybe the last thing I'll say, I don't want this to be too negative, and I realize it's taken a bit of a negative turn, but I think these are these are strategies that people should adopt if you really want to be able to navigate this space. Be wary of hacks, right? Everybody wants to talk about this longevity hack. If somebody says doing this one thing is going to make you live longer, and it's not part of the pillars of Healthspan, they're at best overstating the data. At worst, causing you to do something that's harmful to you. And so be careful.
I will kind of the opposite of that, or the counter to that, which I'm sure you see with OptiSpan as well, is if it is in one of the pillars and you're moving one of those metrics, it tends to move a bunch, right? If we improve deep sleep, we start seeing all sorts of cascading benefits.
Yeah, they're interconnected. Absolutely. Yeah, absolutely. Yeah, and I mean, I think a positive way to look at this, and again, I encourage people to take control of your own health span, right? So become informed. And again, it's not easy. I'm not suggesting that certainly you're not overnight going to get a PhD in biology, right? But become informed, try to find credible sources, and make sure you've got a good, optimally medical professional, but a good resource that you can go to help you know, what should I be measuring, what should I be looking for. And if you see your biomarkers going in the right direction, that's a good sign, whatever you're doing, right? So use data to guide you as opposed to deepfake AI-based YouTube videos.
Yeah. Well, Dr. Kaeberlein, I cannot thank you enough for being one of those credible sources and helping.
I'm trying to be a voice, in the wilderness, but it's hard sometimes.
And helping our listeners and so many others stay informed in this space as well. It is not as fast moving as maybe the influencers want us to believe, but with AI and others, I mean, it is faster moving than it's ever been in human history as well.
And again, I'm very optimistic that we have good tools today for assessing where people are at and helping people add 10, 15 years on average to health span. I don't know about lifespan, but I think we know enough where we can have a big impact, especially if we talk about the average American, on health span. And I think it's not as expensive as a lot of people have been led to believe. Like there's this myth that it's only for billionaires. I mean, I think, yes, of course, the more resources you have, the larger the spectrum of diagnostics you can get access to. And of course, you're going to get access to higher quality healthcare. I mean, it's unfortunate. That's just the reality. But it's not tens of thousands of dollars. I think, in one of our programs at OptiSpan, we have a corporate healthcare program, right? So we're doing corporate healthcare for Sabi Corporation employees. For a couple $100 a month, I think that's about the 80-20 on the $100,000 healthcare programs. You can do a pretty good set of diagnostics and get access to reasonable healthcare for about a couple $100 a month. Now, of course, that's outside of insurance. And I think this is also one of the things that I try to encourage people to at least think about. I think there's a culture in the United States, at least, just because of the way our healthcare system is paid for, that people have this gut reaction, well, if insurance doesn't cover it, I'm not going to do it, right? And I think you got to, your health is more important than that, right? So I understand where that comes from, but you should be willing to invest, in my view, as much as you can in your health. Yeah. And so think about where you're allocating your economic resources and whether they're being allocated towards the things that are most important in your life. And I would argue health is probably more important than most people give it credit for.
And we do see as societies get richer, right, the proportion of income that goes to health and healthcare is bigger, though it's typically sick care. But I would say the signal from OptiSpan, from Function, from Superpower, these companies coming out, people are starting, it hasn't gone to hundreds of millions of people yet, but people are more willing.
There is a broader recognition. And again, for some of the people that I struggle with in this space, Brian Johnson, David Sinclair, they also have done good in raising awareness around this topic, right? So it's not as if it's all bad stuff. So it's great that more people are paying attention. I think now the question is, how do we actually help those people get access to the real information? And I think Function Health is an interesting example. I'll be interested to see where they go. I actually think it is a net negative for people to give them access to data without giving them any way to act on that data, right? Without providing medical care. I understand why they do it, because you can make more money and it's easier to do it outside of the regulatory system. And I think it's detrimental to most people who don't have a good physician that they can then go to. This is what I was getting at having somebody who can help you navigate that data. If you get a function health report and you take it to your typical primary care doctor, they're gonna be like, get out of my face. I don't know what to do with this.
Is this where Gemini and ChatGPT can, because you could ostensibly upload the report. What should I be worried about? What should I be working on?
And they're reasonably good, but they make mistakes, right? And even if they tell you what to do, if you don't have a way to get access to a prescription medication that you need. So I'm not trying to be hypercritical of function health. I just wish they would bite the bullet, do it the hard way, and give people medical care.
Yeah. And maybe that's on the product roadmap, right? Like, as building a company, you kind of have to start and get your initial land grab and then expand. Well, Dr. Kaeberlein, thank you so much. This has been a complete pleasure. I could keep asking you questions for much, much longer. As I think you saw right before your talk when I was just peppering you.
Yeah. No, we can definitely do a part 2 at some point.
Oh, I would love that. Thank you so much. I know
welcome.
You're traveling this week, so safe travels, and look forward to continuing to follow your work.
Thank you.
Thank you for joining us on today's episode of the Home of Healthspan podcast. And remember, you can always find the products, practices, and routines mentioned by today's guests, as well as many other Healthspan role models on alively.com. Enjoy a lively day.